In this example, we're asked to integrate x multiplied by e to the minus 2x. This is a typical integration by parts question because it has a product of a polynomial and an exponential function. So we'll use our equation here for integration by parts to solve it. So begin by choosing u and dv. U will be the thing that when we differentiate it, it becomes easier. In this case, dx is the derivative of x. And dv is something that we want to be able to easily take the integral of. The integral of e to the minus 2x is e to the minus 2x over minus 2. If you're not sure why it's over minus 2, off to the side on some paper, just work out by itself the integral of e to the minus 2x dx by using u substitution and setting u equal to the exponent. And hopefully you'll see why that's the answer. If you've done enough practice now, you should be able to do that without needing this extra part. So if we put the pieces back in now, uv minus the integral of v du, we get u times v minus the integral of v du. So there's our parts put back in. Integration by parts, again, gives us a different form of an integral that we can hopefully solve. Sometimes we might have to do integration by parts again or some other technique. In this case, we can solve this directly. This part we can keep and put the minus up top here. This is plus 1/2. And we'll write it in two steps here. The integral of minus 2x dx. We just took out the 1 over 2, or minus 1 over 2. Integral of e to the minus 2x, well, that's the same thing we did here, or the same thing you worked out on your own over here. So we can do that directly. It's going to be minus 1 over 4 e to the minus 2x plus c. And so that's our final answer for that one. The next example is a similar form, but instead of a polynomial and an exponential function, it's a polynomial and a trig function. This will work just as well. In this example, we'll use a table to solve it. We could do just as we did the previous example, but to make sure you've seen examples both ways, we'll do this one this way. Choose u so that when you differentiate it's easier. So x becomes 1 and then 0. Derivative of cosine, or integral of cosine, because it's dv, sorry. So integral of cosine is sine. Integral of sine is minus cosine. The signs alternate, plus, minus, plus. Multiply on the diagonal, integrate across the bottom, write the answer. So x sine x minus times minus is plus cosine x plus or minus the integral of 0, which is a constant, so it doesn't matter if we write plus or minus, just a constant. This is really just using the formula. We took the derivative here, so this is u du. We took the integral here, so this is dv and v. So if you look at this, this is actually u times v, u times v, minus the integral of v. So the integral of v is this. So it's already done, so minus minus gave plus, times du, and du is 1. So there's the integral of v du. So it is just the formula in a different form, but feel free to do whichever way you're most comfortable with.